Hey guys, welcome back to our channel. So this channel, Everyday Data Science, is all about trying to learn the different concepts involved in data science by practicing a lot of questions. In this video, I'm going to solve this question on LeetCode regarding the number of seniors and juniors to join the company. The difficulty level of this question is hard, and this question has been asked in Wayfair interviews over the past 6 months a couple of times, right? Let's jump right in. We are given a table called candidates with 3 different columns, right? Employee ID, experience and salary. Employee ID being the primary key column for this table. Experience is an enum with one of the values, senior or junior. Each row of this table indicates the ID of a candidate, their monthly salary and their experience, okay? A company wants to hire new employees. The budget of the company for the salaries is $70,000. The company's criteria for hiring are hiring the largest number of seniors, okay? After hiring the maximum number of seniors, use the remaining budget to hire the largest number of juniors, okay? We are asked to write a SQL query to find the number of seniors and juniors hired under the mentioned criteria. The order of the result doesn't matter, right? So let's go through this example, right? So here we have 3 different seniors and 3 different juniors, right? So they have in total monthly budget of $70,000, right? Now they will start with hiring seniors, right? So for this one, the monthly salary is 20,000, 20,000 and 50,000, right? Now they want to hire the maximum number of seniors, right? So if you see, if we hire this senior, right? So $20,000, then we hire this senior, right? So $40,000. Then can we hire the third senior? No, because 40 plus 50, that is going to be $90,000, which is more than the $70,000, right? Now let's see, we can hire this one, right? So any of these two and this one, right? So 50 plus 20, that is going to be $70,000. So 2 seniors can be hired. But in that case, there is no remaining budget for a junior one to be hired, right? So let's say if we hire senior, like these 2 seniors, right? So $40,000, you still have $30,000 remaining. Then you can hire these 2 juniors as well, right? So now in this case, you can maximize the number of seniors and then maximize the number of juniors that you can hire with the remaining budget. And you are still left with $10,000, right? So that is what we are having. Experience senior 2, junior 2. Okay, now let's consider another example, right? So in this case, we have again 3 different seniors and 3 different juniors. Now the problem here is that all the seniors have their monthly salary of $80,000, which is more than $70,000, right? So you cannot hire any senior in this case. So all your budget is going to be used to hire the juniors, right? So you can hire this one, so 20,000 plus you can also hire this one, so 60,000, and still you are remaining with $10,000. So in this case, you can hire 0 seniors, but all the 3 juniors, and that is what we need to do. Okay, so to do this, if you see the question again, right, it says we need to hire the largest number of seniors, and then after hiring the maximum number of seniors, use the remaining budget to hire the largest number of juniors as well, right? So basically, if you are going to hire a large amount of seniors or juniors, so basically if you hire the people with the lowest salary, then obviously you can have more, right? Because if you can hire 2 people at $10,000, let's say seniors, then you are still left with $50,000, which you can use for juniors. But let's say you hire a person like with $50,000 who is a senior, then you can only hire 1 senior and you only are remaining with $20,000, right, to hire the juniors. So that is, so you get the idea that basically this question says that we need to hire the people with the lowest salary, right? Because that is the way you can maximize the largest number of seniors, right? So what we can do this is with this table, right? With this candidates table, we can calculate the running total of the different seniors in their ascending order of salary, right? So let me just write this, that will be more clear, right? So from this candidates table, right, what we are doing is let's return all the columns and then make a new column which calculates the running total for seniors as well as juniors, right? So since we are using a window function, we need to write the over clause, right? So over then partition by the experience part, right? So experience, because for juniors and seniors we need to calculate the running total separately, right? Then you order by salary in increasing order, right? Also here you need to calculate the running total, right? So you need to tell this SQL that this is my window, right? So how do you define windows in SQL? You can use either rows between or range between. Let me know in the comment section what is the difference between rows between and range between. Basically, what is the limitation of range between, right? So you write rows between, right, unbounded preceding and current row. So basically this will start from the very start, and then for each of the rows, right, it will calculate the running total. And what do we need to do? We need to calculate the sum of the salary, right? I will just take an example also, how this query is running so that it is more clear. And let's alias this as running total, right? Let me just go ahead and run this. Obviously this is not complete, this is going to return a wrong answer, but let's see what we are getting. So for seniors, right, so for this one, seniors, we arranged by salary in increasing order, right? So to senior salary, and the obviously for at this point the total running salary is, or running total is 20,000, right? Now again there is another one, 11 senior 20,000, and now you have 20 plus 20, that is 40. Similarly, if you add 50,000 to it, you have 90,000. Now for juniors you have 10, then 10 plus 10 20, then 20 plus 40, that is 60,000, right? So we have that. Now what we can do, so let's store this in a common table expression. So with CTE as, and this entire thing goes into parentheses, right? So let me just copy this here so that we can understand this, what we are trying to do in this case, right? So here if I add this, and then if I write running total in this, because this is the column that we are making with this with this query. So obviously what we are doing, firstly we are doing partition by experience, right? So it will create partition. So let's say juniors and seniors, they are partitioned by, right? So let's say it comes here, right? Because junior is one partition and then senior is one partition, right? So partition by this, and then it says order by salary, right, in increasing manner, right? So this is ordered by salary in increasing manner, this is also ordered by salary in increasing manner. Now what it does is, for each of these partition, it says rows between unbounded preceding, that is start from the very start, and wherever your cursor is at that current row, you calculate the sum of the salary. So for example, when your cursor is here, what it will do? It will just say, okay, start from the very beginning. So this is the very beginning. So the very beginning and the current row is same. So it will say, okay, running total is equal to this one, right? Now the cursor goes here. So now start from the very beginning and your cursor is here, right? So it will calculate 10,000 plus 10,000, right? So now you have 20,000, right? Similarly, now the cursor is here, and then it will be 60,000, right? Now again, for this partition, this is now the beginning. So it is 20,000, then 20 plus 20, that is 40,000, right? So 40,000, and then you have 40 plus 50, that is 90,000, right? So this is what this common table expression is. Now what we need to do is, we need to, based on this, see how many maximum number of seniors that you can hire, right? So now if you see this, right, if you hire this one, right, so your how much you are going to spend? 20,000. If you hire these two combined, right, so 2 and 11, you are going to spend 40,000. Can you hire all three seniors? No, because you are going to spend more than your budget. So you can hire these two, right? So you have total 40,000 you are going to spend, right? So how much budget is remaining? 70 minus 40, that is $30,000, right? So let's go step by step and see how many seniors we can hire, right? So from this common table expression, right, where experience, right, where experience is equal to senior, right, and running total, right, running total is less than or equal to $70,000, right? So because because wherever your running total is getting more than 70,000, right, so that is obviously that person is not going to be hired, right, anyway, because you need to maximize the number of seniors that you are going to hire, right? So you are only keeping those rows where experience is equal to senior and running total is less than or equal to 70,000, right? So obviously in this case, this row is going to be excluded. Obviously these three rows are already excluded from this because we are only keeping experience is equal to senior, right? So now when you have these two rows, what you can do, you can return the word senior and count this employee's ID, right? And that is going to be the number of employees that are senior whose running total is less than or equal to $70,000, which you can accept as a candidate, right? So you can write experience, right, and then count, since employee ID, as the question says, employee ID is the primary key column, right? So you don't need to do anything extra like distinct and all, just count employee ID, and right, and this is going to be basically as accepted candidates, right? Now what is one problem that you can see with this? Okay, you are not going to see that problem in this example, but you can see that in the second example. Again, if you look at this, right, so here you have 80, 80 and 80, right? So this is going to be 80, 160, 240, right? When you write, when experience is equal to senior and running total less than equal to 70,000, obviously none of the three rows are going to have that, right? So basically this entire thing will be having null, right? And when you return experience, it is going to return null, right? So that is a problem. So because in your output anyway, even if you don't have anything, you need to return senior as the value in the experience column, right? Junior as the value in the experience column. So that is why instead of writing experience here, right, you need to write the word senior as experience, right? Because you basically what you are doing, you are insert this value in a column named experience. Okay, now again, if you consider the same thing, right, here there is nothing, right, in this example. So if there is nothing, what are you counting? Nothing, right? So it is also going to be null. So you remember in our previous videos we have discussed a function called if null, that if you are getting null out of something, then you can substitute with whatever you require. In this case we require it as 0. So what you can do is you can simply write if null, right, and if this value, this count of employee ID comes out to be null, you just simply replace this with 0, right? And this is for the first row, right? This is still not complete, right? But let me just run this to see, like, what we are trying to get, we are on the right path or not, right? So let me just run this. Okay, so still wrong answer because it's still not complete. But if you see now, you have senior and how many people accepted candidates? 2, right? Okay, so this is cool. Okay, let me get that common table expression back, right? So that, because this is our basis, right? Based on which we are developing our solution, right? Okay, this is done. Now we need to do the same thing with junior, right? So again, from this common table expression, right, where experience is equal to junior, right, experience is equal to junior and running total, right, running total is less than equal to. Now what is going to be the case in this? So here you had, since you are hiring seniors first, right? Here if you see the question, we are hiring the largest number of seniors first, and then whatever is left, you are hiring largest number of juniors. So now you have spent some amount or all amount, for hiring the seniors, right? So the amount that you are left with is not the entire 70,000, but 70,000 minus whatever you spent hiring these people, right? So what do? You that, okay, 70,000. So for example, here in this particular example, right? So you spent 40,000 because you had these two seniors. So you spent 40,000. So what is the remaining amount? 70,000 minus 40,000, right? So that is going to be 30,000. But how do you know and generalize this using a code? So you can write 70,000 minus, now what you are doing is from this, right? So from this entire thing, if you can get the maximum one, right? So when you're running total, so from this common table expression where experience is equal to senior and running total less than equal to 70,000, we remember that these are the two rows that are going to come from this, right? And if you see the maximum out of this column, right, of this running total column, so that is the amount that you are going to spend, right? So if you can get that maximum value out of it, right, so that is what you can subtract from 70,000, and that is your remaining budget, right? So what we can do is we can write same stuff, right? So from the common table expression where experience is equal to senior, right, and your running total, right, and your running total is less than equal to $70,000, then what you're doing is you are returning max of the running total column, right? So max of running total column. Okay, now there is still a problem with this. Why? Again, go to the second example, right? Here, if you do the same stuff, right? If you just look at this part, right? Return maximum of from this common table expression where experience is equal to senior and running total less than equal to 70,000. Obviously it is going to be 80, 160, 240 as we discussed, right? So this entire thing is going to be null, and obviously the max part, like what are you getting max out of if there is nothing, right? So in that case, what you do is you need to again use the same stuff, right? So if null, this part is in coming out to be null, then you replace it with 0, right? So if null, right, if null, this entire thing is null, so you replace it with 0, and now this is going to satisfy both the conditions, right? So in this case it is going to take, okay, 40,000, right? And in this case, okay, so since there is nothing, so basically you have hired no one from the senior, so that is, you have spent $0 in hiring seniors, so you have 70,000 minus 0, that is entire $70,000 budget to hire juniors, right? Similarly, what you can do is you can return the same stuff, right? You can return the same stuff here, just copy this and just replace this, right? So select and replace this by junior, right? So junior as experience, and again count the employee IDs if null, 0 as accepted candidates, right? Okay, now once you have these two, since you have to have both of them, so all you do is you just write union, right? Okay, so this looks good. Let me remove this, right? Let me remove this and we can run this to see what happens. So let's run this. So this is accepted, our output is same as expected output. Let me go ahead and submit it to see if passes all the test cases. So yep, this passes all the test cases, and this is how I do it. Again, yes, it is hard difficulty, but if you actually follow the logic, it is very, very simple question. All you had to do was for each of the experienced candidates, right, you calculated the running total by providing window frames using the function or using the keywords rows between, then unbounded preceding means start from the very starting, current row means wherever your cursor is at that point, and then you calculated the running totals, and then for seniors you calculated your spending budget, running total is less than equal to $70,000, then you counted the number of employees, and you also took care that in case it is null, then you have to replace it by 0 because of this example, right? right? And then similarly you did that for junior, and in this way the running total should be 70,000 minus whatever you have spent for hiring seniors, right? And in that case, if that is going to be null, then you are basically assigning 0. That is, you have not spent anything while hiring seniors, so you have the entire budget to hire the juniors. Same stuff for counting the employee IDs, so that if it comes out to be null, you just replace it with 0. And yes, this is how we do it. Let me know if there is a better way or a more efficient way you can think of to solve this question. Let the solution be in the comment section below, and until then I will see you guys in the next video.